Okay, guys, let's move on. Chapter 15, Section 2, Trigonometric Functions of Non-Acute Angles. So we'll be talking about reference angles, special angles as reference angles, and then finding angle measures with special angles. So a reference angle for an angle theta is the positive acute angle made by the terminal side of angle theta in the x-axis. So if we look at this first example here, we have I'm just trying to fix my highlighter. So here's the angle that we are given, theta. So on the other side of that, we have this reference angle, and that is what we call theta prime. So that would be the reference angle. And here we have, here's our initial angle, and then our reference angle would be this one right here. Okay, that'd be theta prime. And on the last one, we're coming all the way around here. And this small piece of angle here would be theta prime. So if you can look at this, and you maybe want to think of it this way, theta prime equals 180 minus theta. On this one, if it's in quadrant 3, theta prime is equal to theta minus 180. And on the final one, theta prime is equal to 360 minus theta. So those are the three possibilities, okay? If you remember, this is quadrant 1, quadrant 2, here's quadrant 3, and here's quadrant 4 down there. So in the first example, that's in quadrant 2. The ray is in quadrant 2. In the second, the ray is in quadrant 3, and in the third, the ray is in quadrant 4. All right, so a common error is to find the reference angle by using the terminal side of theta in the y-axis. You never use the y-axis, we only use the x-axis. Okay, so the reference angle is always found with reference to the x-axis. So we want to find the reference angle for an angle of 218 degrees. All right, so the first thing we want to keep in mind, again, is if it's greater than, okay, and let's talk about this real quick while we're here. Here's between 0 and 90, and that's quadrant 1. Quadrant 2 is from, oops, not 3, 2, try this again. Quadrant 2 is greater from 90 to 180. Here's from 180 to 270 is in quadrant 3, and quadrant 4 is from 270 to 360. Okay, so this measurement of this angle is greater than 180. So to find our reference angle, we would take 218 minus 180, and that gives us 38 degrees. So for theta 218, the reference angle is theta prime is 38. Okay, find the reference angle for an angle of 1387 degrees. Now this situation is, we want to first got to find a coterminal angle between 0 and 360. So you're going to divide 1387 by 360, and you get a quotient of about 3.9. So you're going to take less than that. You're going to say 3 times 360. So 1387 minus 3 times 360, and you've got 307 degrees left. So the reference angle for 307 degrees, and thus for 1387 degrees, is 360 minus 307, or 53 degrees. Okay, so that angle would be basically spinning around that axis. Okay, this type of mathematics becomes very important in physics. You're going to see some of this stuff next year in physics. So keep in mind some of this thought process when you see it again. Okay, so reference angle theta prime, where for theta, where 0 is less than, theta is less than 360. So again, in quadrant 1, theta prime is equal to theta. Quadrant 2, theta prime is equal to 180 minus theta. Quadrant 3, theta prime is equal to theta minus 180. And quadrant 4, theta prime is equal to 360 minus theta. Okay, so the quadrant 3 can be the most confusing. That's where we're going to switch those two. All right. So find the value of the 6 trig functions now for 210 degrees. So the first thing we want to do is we want to come up with our reference angle. And our reference angle for the 210 degrees is 30. So now that we know that, so we're choosing point P on the terminal side of the angle, so the distance from the origin to P is 2. So the reason we want to do that, we do have a 30, 60, 90 right triangle. So because we know that these are going to be in this ratio, the hypotenuse is at 2, this is at, y is at 1, and x is the ratio of square root of 3. So now we can find, based upon that, r equals 2, x is equal to the square root of negative 3. Okay, and that's the other thing, because this is on the left-hand side of y, it's got to be negative square root of 3. Okay, since this 1 is down, this has got to be negative 1. Okay, it's the direction. This is all about direction, don't think about numbers. So, negative square root of 3, negative 1, and then positive 2 is the length for the radius. Okay. Now, we're going to continue on. So the sine of 210, okay, is equal to theta here. So it would be negative 1 over 2, which is equal to negative 1/2. Okay. Now notice down here, because the cosecant is always the reciprocal of the sine. So all we have to do is take that reciprocal, and so we're going to flip over 2 over 1, negative 1, and that becomes negative 2. Next we'll do cosine. Cosine is adjacent over hypotenuse. Well, the adjacent is a negative square root of 3 over 2 is the hypotenuse, so it's negative square root of 3 over 2. The secant is always the reciprocal of the cosine. So we would be taking that, going 2 over the negative square root of 3, and then that's going to be negative 2 square root of 3 over 3, right? We have to rationalize the denominator. And then the last one is our tangents. So negative 1, tangent of 210 is negative 1 over negative square root of 3. Cotangent would be negative 3 over the negative square root, or negative 1, excuse me, negative square root of 3 over negative 1. So we just have to simplify those. So the tangent of 210 would be negative, excuse me, square root of 3 over 3, and the cotangent is the square root of 3. Okay, so finding trig function values for any non-quadrantal angle theta. Non-quadrantal means it's not a divisible amount by 90. So your quadrantal angles would be 90, 180, and 270, or 360. Okay, so those are quadrantal. Non-quadrantal is any values that are not those four. So if theta is greater than 360 or if theta is less than 0, find a coterminal angle by adding or subtracting 360 as many times as needed to get an angle greater than 0 degrees but less than 360. Then find the reference angle using the methodology we showed you earlier. Then find the trig function values for the reference angle theta prime. Then determine the correct signs for the values found in step 3. This gives the values of the trig functions for those angles. Let's try this again. Negative angles go clockwise. Okay. Positive angles go counterclockwise. Okay. So, in this case, an angle of negative 240 is coterminal with an angle of negative 240 plus 360, which is 120. So the reference angle is 60. So now we have, again, our 30, 60, 90 right triangle situation, right? So the cosine of negative 240 is equal to the cosine of 120, which is equal to negative cosine of 60, which is equal to negative 1/2. Okay. Okay, so find the exact value of the tangent of 275. So the first thing we're going to do is subtract 360, excuse me, from 675, and we find out that that angle is 350 degrees. So you look here, this is what I was talking about earlier. This is rotating around here, just like this. So that would be a 675 degree angle. So you go ahead and you find the coterminal angle. So 675 minus 360 is 315. From there, you subtract 360 minus 315 and you get 40 tangent of negative 45, as this angle is formed by going this way. Okay, so it comes back the other direction. So it's negative tangent of 45, which would be negative 1. Alright, so now we want to evaluate the cosine of 120 degrees plus 2 times the sine squared of 60 degrees minus the tangent squared of 30 degrees. So, keeping in mind those are the values. So the cosine of 120 is negative 1/2. The sine of 60 is square root of 3 over 2. And the tangent of 30 is the square root of 3 over 3. So we would take those values now. So we take cosine of 120, that's equal to negative 1/2. 2 times the sine squared of 60, well, you have 2 here, times the square root of 3 over 2 quantity squared. And then the final part of the puzzle is right here. Okay, minus square root of 3 over 3 quantity squared. From here, we simplify. You get negative 1/2 plus 2 times 3/4 minus 3/9, which is equal to 2/3. So let's resimplify. Evaluate the cosine of 780 degrees by first expressing the function in terms of an angle between 0 and 360. So cosine of 780 degrees is equal to the cosine of 780 degrees minus 2 times 360. 2 times 360 is 720. So 780 minus 720 is the cosine of 60 degrees. Well, the cosine of 60 degrees is 1/2. And we would be done. Evaluate the tangent of negative 405 degrees by first expressing the function in terms of an angle between 0 and 360. So this will be a clockwise angle. So the tangent of negative 405 is equal to the tangent of negative 405 plus, because we want to have a smaller value here, 2 times 360. So tangent of 315 degrees lies in quadrant 4. Its reference angle is 45 degrees. So opposite, so it would be negative tangent of 45. So that would be the opposite over the adjacent, which is always going to be 1. In this case, it would be negative because it's in the 4th quadrant. All right. Find all the values of theta if theta is in the interval between 0 and 360 degrees. And the cosine of theta is negative square root of 2 over 2. So since this is negative, theta must lie in quadrants 2 or 3. And the absolute value of the cosine of theta is the square root of 2 over 2, so the reference angle is 45. Therefore, the angles in quadrant 2 be 180 minus 45, or 135. And the angle in quadrant 3 would be 180 plus 45, which is 225.
That's all, folks.
We're almost home, boys.